Hello and welcome back to my channel. Today we are diving into lesson 10 of exploring statistics in agricultural research. In this video, we'll delve into blocking. The objective of this video is to help you understand blocking in agricultural research. Let's get started. Blocking. We are saying that blocking is one of the principles for experimental design. Remember, we already defined the randomization. We also defined replication. These are the principles of experimental designs. So now we have to define what is blocking. We are saying that blocking is nothing but the arrangement of experimental units that are similar to one another. It's just an arrangement. Arrangement of experimental units, those EUs that are similar to one another. So the blocking is whereby you just arrange your experimental units that are similar to one another in groups. So now when you arrange them in groups, those groups, we call them the blocks. Remember, where we put our treatment, we put our treatment on experimental units. So those experimental units, we have to make sure that they are similar. If they are not similar, you have to group them. For example, you are designing your experiment, and then you notice that your experimental units are not the same. Therefore, you have to group them. That is what we call blocking. Now, let's take for example, the researcher is interested to plant in this land. The researcher wants to know the effect of fertilizer in this land. Now, as a researcher, you observe the land. You observe where you are going to put your treatment, which is the experimental unit. Once you observe the land, you find out that the other side of the land experienced the soil erosion. So, since this side there is a soil erosion, the other side there is no soil erosion. So as a researcher, you are forced now to group your plots, not having the plots all over your land. You have to group your plots based on the soil erosion history. Now we are saying this side was the soil erosion. Then on the other side, there is no soil erosion. So what you have to do, you have to make sure that you put your plots around this one of soil erosion. Maybe you have these 6 plots. You put treatment A, B, C, G, E, and F. Maybe your interest is to know the effect of these fertilizers, which is your treatment. Now, everything that you are doing from this side of soil erosion, make sure that we are also doing it on the other side of no soil erosion. Because now, as a researcher, you can, of course, you have to do randomly. You can put A there, you put B, C, D, you have E there, you have F. Because once you only have your blocks in one side where there is soil erosion, once you get your results, you may think that that particular fertilizer is working. Only find out it's because of there was a soil erosion on that plot. So it's better to make sure that whatever you are doing on the other side where you notice that there is no similar, you also do on the other side. So since we have treatment A under the soil erosion group, we must also have that treatment A under the non-soil erosion, so that we can see whether this treatment A is working or not. There are many examples that we can do when it comes to blocking, but you have to make sure that you only block once you notice that those factors they will receive your treatment are not the same, which is the experimental units are heterogeneous. So you have to group them to make sure that you group the way they are similar, which is the blocks, those different groups. Thank you for watching until the end. To recap, we have covered blocking. We designed blocking as one of the principles of experimental designs. Remember, blocking is just the arrangement of the experimental units that are similar. If you have any questions or topics you would like me to explore, please leave them in the comments below. Do not forget to subscribe, hit that like button and share this video. See you in the next one.